I have talked before how you can think of stoichiometry as kind of like a recipe in which we have our ingredients, the reactants, and then we have our product. And the coefficients for each of the different compounds or elements tells us the amounts we need. I need 1 mole of nitrogen and 3 moles of hydrogen to produce 2 moles of ammonia. Now, as I said, it's like a recipe. So let's suppose that you were going to make a cake and you needed some eggs, and maybe the recipe calls for 12 eggs and you've only got 6. Now, you could go to the store and get some more eggs, or you could decide you just don't really want to do that and you're going to just go with the 6 you've got. In other words, you're going to make half of the recipe. The number of eggs you had limits how much you can produce. And so the same idea is here is we have to figure out which of our reactants, which of our ingredients is going to limit how much, in this case ammonia, we can actually produce. Now, the first step, if you will, is we have to be in moles. So we need to go to moles for both of our ingredients. And that's the thing to note. We have actually 28 grams here and 25 grams here, and we want to know how much of that we're going to make. But in order to do that, I have to know whether or not these in fact fit that 1:3 mole ratio between the two. So the first thing I have to do is go to moles for both of them. So let's start off with the nitrogen. We have 28 grams times 1 mole over 28 grams, and that gives me 1 mole of nitrogen. Now we also do the hydrogen. We have 25 grams times 1 mole over 2 grams for hydrogen, and that gives us 12.5 moles of the hydrogen. And so that's our first step. We went to moles for both of them. Now, next, we need to use the mole ratio. Remember that the formula says we need to go from 1 to 3. So we're going to check and see whether or not that is true. So we're going to take our 1 mole of nitrogen and then times the mole ratio, 3/1. Now a couple of things. Remember that the mole ratio always has the question mark on top. In other words, what did we want to find out? In this case, we're trying to find out how much hydrogen we would need if we have 1 mole of nitrogen. And the one on the bottom is the one that we started from, or the one we already knew. In this case, the nitrogen. Don't forget that if there's nothing there, it's always a 1. So 1 mole times 3/1 would give us 3 moles of H2 hydrogen gas needed. Okay, and now comes the question. Do we have 3 moles of hydrogen gas? Well, we've got 12.5 moles. So I got plenty of hydrogen, but I'm going to use up all my nitrogen, so this means the nitrogen is the limiting reagent. And again, we can use reactant or reagent equally in this case. Now, the rule is pretty simple, okay? If if you have enough, that's excess. Other one is limiting. So here we had enough hydrogen, so we're going to have excess hydrogen, and therefore the nitrogen is limiting. Now, you can do this either way. I could have started with the hydrogen and go back to the nitrogen to see how much nitrogen I would have done. If I'd have started with the 12.5 and then done a mole ratio of 1/3, because now I'm going the opposite direction, then I would have needed like 4 moles of nitrogen. I don't have 4 moles, so again, the nitrogen would have come out limiting. Now, once I have picked which one is limiting, I then use that to find out how much I'm actually going to produce. So so if you want step 3, use limiting substance to determine product. So nitrogen is limiting. I have 1 mole of that, so 1 mole times, now my mole ratio with the ammonia is 2/1. That's the question mark. That's what I want to find out. So that's going to give me 2 moles of NH3. I want to see how many grams. So now I have to take my 2 moles times, for ammonia it's 17 grams per mole, and so I'm going to produce 34 grams of NH3. Now note that if I had taken the hydrogen, which I'm going to have lots of left over, but if I'd taken that 12.5 moles and then done that times 2/3, which would have given me over 8 moles, I would have been way higher than what I could actually produce. Because I've only got 1 mole of nitrogen, I can only produce 38 grams of ammonia. Now, in question 2, it says, well, so how much of the excess reagent in problem 1 is left over? I used up all the nitrogen, but the hydrogen, I had 12.5. I only used 3 because it's 3:1. So for every 1 mole, I'm going to use 3. So we had 12.5 moles of H2. We used only 3 moles. So 12.5 moles, subtract 3 moles, means that 9.5 moles are unused. And then since I want to know how much hydrogen, assume unless it explicitly says moles, so we got to go back to grams. So 9.5 moles times 2 grams per mole gives me 19 grams of H2 in excess. And so all of the nitrogen got used up. We produced 34 grams of ammonia, and we had 19 grams of hydrogen left over. So that's the basic idea of doing a limiting reagent problem. So let's look at a second example. And again, one of the ways that you can tell that this might be a limiting reactant type problem is that I have amounts for more than one of the reactants. And so I need to figure out which one will limit me, or will they actually come out with a mole ratio of 1:2 in this case. So again, always a good idea to label your equation. So we've got 50 grams here, and I have 75 grams here. And eventually I want to know how much hydrogen I'm going to produce. So first we're going to go to our moles. So 50 grams times 1 mole. Let's see, for magnesium, 24 grams per mole. And that's going to give me 2.083 moles for the magnesium. For the hydrochloric, I'm going to take my 75 grams times 1 mole over, in this case, 36 grams. We just used 35 for chlorine. Only had 1 plus 1 for the hydrogen, so it's 36 grams. And that comes out to 2.083 moles of HCl. Now, note that in this case I have the same mole amount for both of them. However, I have a mole ratio of 1 to 2. So that says really for every 1 mole of magnesium, I should have 2 moles of hydrochloric acid in this case. So let's go ahead to our second step. Do the mole ratio. So we're going to take our 2.083 moles times 2 over 1, which is going to give me 4.163 moles of HCl needed. I don't have that much. I've only got 2.08. In other words, I'm going to run out of HCl if I actually wanted to use all the magnesium. Therefore, the HCl is limiting. Which means then that's the one I will use to figure out how much hydrogen I'm actually going to produce. So take my 2.083 moles times, now in this case the mole ratio, again there's nothing in front of the H2, so that's a 1. So my mole ratio will be 1 over 2 because I'm looking at the hydrogen compared to the HCl. This gives me 1.04 moles of H2 produced. And then notice this case I wanted volume of H2. I didn't want the grams, I wanted volume. So I'm going to need to now take that 1.04 moles times, for volume, 22.4 liters per 1 mole. And let's see, that will give me basically 23.3 liters of H2 produced. Now, like we did in problem 2, we want to see how much of the excess reagent was left over. Just as a reminder, the HCl was limiting, which then means the magnesium, the Mg, has excess. Now, how much excess? Okay, so we're going to take the amount of HCl we had, 2.083 times, now we're going to do the mole ratio comparing the magnesium to the hydrochloric, which should be, again, nothing in front, that's a 1, so 1 over 2, which means 1.04 moles of Mg used, half of it. And, therefore, we kind of know since I used half, I'm going to end up using half of the 50, so that means 25 grams. But just to, go back to grams, 1.04 moles times, in this case, 24 grams per mole. And so we're going to use 25 grams of magnesium. And of course, the other way you could have looked at it is I had 2.083. I subtract the 1.0415 if you want all the decimals. And so 1.0415 moles in excess. And of course, this is the part was used, and this is the part we started with. And so there we have another problem. Again, it is the mole amounts. In addition to that, it is the mole amounts with the mole ratio that tells us what is limiting. All right, last example here. We have some silver nitrate and sodium phosphate. We have 200 grams of each, so we actually have the same gram amount of each one, but we have to go to moles. So first off, for the silver nitrate, 200 grams, 1 mole over 170 grams, and that's going to give us 1.176 moles of silver nitrate. And I know not everyone likes to do all this labeling, but at least it does keep straight what you're looking at. So here I was doing the silver nitrate. Then we also have the 200 grams. Note they both are 200, so that would be easy to get confused. And so we go 1 mole over 164 grams. And that one will equal 1.220 moles. And this is the sodium phosphate. Now, just as a reminder, to add up these amounts, you have to go back to the periodic table. 16 for each oxygen, 14 for the nitrogen, and then the rest of it is the silver. In this case, 3 sodiums here, 1 phosphorus, 4 oxygens to get to my 164. All right, so now that I have my mole amounts, and they're not that far off. In fact, they'd both be 1.2 if I'd only gone to 1 decimal place. And probably that would have been good enough. I just put in a few extra just in case. We'll do the mole ratio. And again, I'm going to start with the first one. Notice in each one of these, 1, 3, and 5 here, I start with the first one and then look at the second one using the mole ratio. So in this case, the mole ratio is going to be 1/3 of that. And so I'm going to take my silver nitrate, 1.176 moles, times 1/3 and that's going to give me 0.392 moles of Na3 PO4 needed. I have 1.22. I'm only going to need 0.394. So when I have extra, I have enough. So that means the other one is limiting. And so the AgNO3 is the one that is limiting. And when we do the last part, it'll be, of course, the sodium phosphate, this part, that will have excess. So that's the one I'm going to use. I should have marked things. Let's see, I had 200 grams here, 200 grams here, and the one I want is the silver phosphate, so that's this one here. That's the one that I want to know how much we've got. Turns out that that'll also be a 1 to 3, so 1.176 moles times 1 over 3 will give me 0.392 moles of Ag3PO4 produced. And then we take the 0.392 moles times, and I need 3 silvers, 1 phosphorus, 4. That adds up to 419. And so we end up with 164 grams of the Ag3PO4 produced. So, just to repeat, we went to moles of each one of them. Then we did the mole ratio step, comparing the first one to the second one using the coefficients. The one we want to find out on top, the one we're starting from on the bottom. So that gave me that much is needed. I have enough, therefore the first one is limiting. When I don't have enough, which is what happened in an earlier problem, then that one would be the limiting one. So the limiting one is then the one I use to find out how much I produce. In this case, it's happened to have the same mole ratio, 1 over 3. That was just coincidence. That's not necessarily true. And then finally taking my moles and going back to grams to see how much was produced. Now, as we mentioned up here, that's how much Na3PO4 was needed. So we had 1.22 moles of Na3PO4 used 0.392 moles. So if we subtract, we then have how much was in excess. So 1.22 moles subtract 0.392 moles gives us 0.828. And then times the 164 grams per 1 mole. And so 135 grams in excess. Now, kind of a shortcut, since basically I used 1/3, then it's 1/3 of the 200 that was used, so therefore 2/3 of the 200 was unused. Kind of a shortcut that I could go there. So, let's see. And so that's one way to look at it as well. Now, the key to all of these problems is, and really there's only two possibilities. One of the possibilities is I have just the right amount of both of them, in which case they both get used up in their entirety and I have no excess. Or one of them limits and the other one has excess. And so in all of these problems we had one of them limited and the other one was in excess.